Today, before we really start the lesson or anything, I want to show you a little video. So just watch this video carefully. You may have seen it before. Whoops. So I better find the video again. So you may be wondering why I showed you that video. Well, as much as possible, I want to kind of pique your interest and help you understand why we're learning some of the math we're doing. If you really like that video, you can rewind and watch it again. It's a pretty cool video, seeing that guy hit that little kiddie pool. How did they figure out where that kiddie pool needed to go? How did they figure out the ramp and how steep the ramp needed to be, all of that sort of stuff? Well, in today's lesson, where we're analyzing quadratic functions, we're going to talk about some of the things you need to know to do something exactly like that. And in fact, later on in this unit, we're going to do a project called a catapult project. Now, if you're in Physics 20, you've done a catapult project, but our catapult project is very different from the one you do in physics. You don't actually build a catapult. We actually use the catapult to study some things. You'll notice in the video that those guys had to determine where to put the pool so that guy would hit it. Well, the pool is like an x-intercept on a graph. So we're going to talk about analyzing quadratic functions, which is what the title of this unit is, to help us determine things like what's the maximum height an object reaches, where are the x-intercepts, all of that sort of stuff. So the math we're going to study in this unit on analyzing quadratic functions is going to let us model something similar to that crazy water slide. And it's going to help you when you work on the catapult project to try and estimate or determine where your object will land when you launch it in the catapult. So all the math we're going to use is going to learn is going to be put into use here. Now, there's quite a bit of terminology in this lesson that we need to look at and we need to learn. The first one we need to talk about is this concept of a quadratic function. Function usually refers to graph. So whenever we're talking about a quadratic function, we're talking about something related to a graph. Now, because we're talking about a function, we're going to write this in function notation. Something else you need to know about quadratic is how we know something is quadratic is the largest exponent on any of our variables is a 2. We can also write this function as an equation in the form y equals ax squared plus bx plus c. When we work with quadratic functions, we usually look for roots and x-intercepts. So often when you're asked to find the roots or the x-intercepts, they're talking about a quadratic function. So what's the difference when we talk about a quadratic equation? Well, very often when we talk about a quadratic equation, we talk about something which is set equal to 0. And in that case, we're looking for the zeros. Yes, the zeros are the same as the roots and the x-intercepts, but the reason we say we're looking for the zeros here is we're looking where x has a value of 0. That's what this equation means. So anytime they ask you to calculate the zeros, they're often talking about an equation, something equal to 0. If they talk about a function, you're probably going to be looking at a graph. Now, when we talk about quadratics, there's two forms of a quadratic function that we usually talk about. There's something called general form, which we looked up here earlier. There is also something called standard form. And we're going to use those terms, general form and standard form, to refer to different ways of expressing an equation. Each of these forms give us different pieces of information. You are going to need to be able to convert from general form to standard form and from standard form to general form. And we're going to talk about how to do that algebraically in another lesson. Now, before we go on, I've given each of you this particular picture already. If you don't have it, it's on our wiki. You can download it. But we need to know the different parts of a graph of a quadratic. Now, first of all, you're going to see a quadratic has this U shape. And the official name for the graph of a quadratic is a parabola. So we're going to use that from now on. When we talk about graphing, we're going to talk about graphing a parabola. What are the things you need to be able to identify? Well, one of the first things you need to be able to identify are the x-intercepts, and in this case, there are two of them. When we talk about the x-intercepts, we talk about them as coordinates. In this case, this x-intercept is at 1, and that second x-intercept is at 5. So the coordinates are 1 and 0, and 5 and 0. And we always describe the x-intercepts as coordinates, so you could actually plot them on a graph. The y-intercept, if we look at where this graph crosses the y-axis, it crosses the y-axis way up here at 5, and the coordinates of that point are 0 and 5, because it's 0 on the x-axis and 5 on the y-axis. Vertex, this lowest point, or if we had a parabola which opened downward, this highest point is called our vertex. And we always talk about the vertex as a coordinate as well. So if we look at this, we go over 3 and we go down -4. So the coordinates of the vertex are 3 and -4. What's the minimum value? When they ask you for the minimum value or the maximum value, they're talking about a value of y. And the lowest value of y here is -4. It happens to be the y coordinate of our vertex. The axis of symmetry, that's an imaginary line that is vertical, goes up and down. It cuts or slices our graph in half. Our graph of our parabola is symmetrical. It is two equal pieces. The axis of symmetry always passes through the vertex. Because it's a vertical line, we describe the axis of symmetry as an equation, and any vertical line starts with the equation x equals, because this line only crosses the x-axis. And where does it cross the x-axis? It crosses it at 3, and that value happens to be the x-coordinate of our vertex. The last two things we need to talk about are domain and range. Remember, domain talks about x values, and range talks about y values for our graph. Now this particular parabola, even though it doesn't have arrows on the end of it, it does keep going upwards forever. Upwards and to the left, upwards and to the right. So if we look at what x values are used for this parabola, this graph keeps going to the left forever, and it keeps going to the right forever. So we say the domain is x is an element of real numbers, or it's all real numbers. The range, well, the lowest value on this graph is -4, and we use all values larger than -4, so the range is y is greater than or equal to -4. Now all of these things, x-intercept, y-intercept, vertex, etc., are called the characteristics of a quadratic function. And I abbreviate the word function as Fn. If you are ever asked to list the characteristics of a quadratic function, you need to list all of these things that are here. So you might want to keep this particular sheet handy in case you forget what all the characteristics are. Now, we're going to look at the next page in your workbook, and we're going to look at some of those characteristics again. Now, the first thing it asks us to do is it asks us to graph y equals x squared by completing this table of values. So they gave us some values of x. What we do is we plug these values of x into our equation. If we take -3 squared, it gives us 9 as an answer for y. So what we're doing is we're taking y equals x squared, and in place of x, we're putting in -3. That gives us 9. -2 squared is going to give us 4. -1 squared is 1. 0 squared is 0. And then 1 squared is 1, 2 squared is 4, and 3 squared is 9. So if we actually plot those points on the graph, we've got -3, and 1, 2, 3, and 9. We've got negative 2 and 4. We've got negative 1 and 1, 0 and 0, 1 and 1, 2 and 4, and 3 and 9. So if we plot all those points, this gives us a parabola that looks like that. Again, this parabola happens to open up. Again, they talk about the axis of symmetry here. It's the mirror line. It's the line that splits our graph in half. And in this case, our y-axis happens to be our axis of symmetry. And it says state the equation of the axis of symmetry. Well, remember, an axis of symmetry is a vertical line. So it's always x equals. Where does it cross the x-axis? Crosses it at 0. So here again, it tells us the vertex is either the minimum point or the maximum point. It says label the vertex on the graph and state the coordinates. Well, our vertex is right here, and its coordinates happen to be 0, 0 in this case. It says the maximum or minimum value occurs at the vertex and is represented by the y-coordinate of the vertex. So in this case, because our parabola opens downward, we're going to have a minimum value. If our parabola had opened, the parabola opens upward here, if it had opened downward, we would have had a maximum value. And the minimum value at the vertex is 0. If we look at the domain, again, this graph continues to the left and continues to the right forever. So the domain is all real numbers. The range, well, the lowest value of y is 0, and we're using everything greater than that. So y is greater than or equal to 0 is the range. So those are some quick terms you need to know about graphs of quadratic functions. Now this video is pretty short. We're going to stop here because tomorrow in class, we're going to start by doing some investigations to help you discover some more things about graphs of quadratics. You will understand the graphs much better if you do the investigations and discover things than if I just tell them to you. So we'll see you tomorrow.